Today we're going to test a Twike with a isolation resistance tester. This unit goes up to 2500 volts and, well, it's dangerous. So be sure to know what you're doing when you test these things. The rule of thumb for testing a motor is to double the motor voltage and add 1000 volts. So in my case 2 times 400 plus 1000 gives 1800 and go a little above that. So 2500 is plenty. It's a non-destructive test, so we'll shoot a few milliamperes through the motor, see whether it gets through on the other side, and if so, we have a problem. You should at least have 1 mega ohm of resistance to call it not a short. So I prepared a few wires to be tested. I extracted the motor wires from the motor controller, so we have access without having to take out the motor beforehand, and then we connect ground to the chassis of the controller, which is also the ground of the motor, and we are ready to start the test. Always make sure to not touch the vehicle in the process. And now we can already see that we have a short, because we don't even reach the 2500 volts, and it also stops by itself and blinks dangerously with an exclamation mark. We also don't reach that 1 mega ohm, we only reach around a quarter of that, and that's definitely not enough to drive around with that motor. And then we can try our luck with the phases to each other. So we test from one phase to another. These motors have 3 phases, an AC induction motor that is, and not even 1000 volts, we have 0 volts. It has even worse performance, so we definitely have a short between our motor phases, which means we have to extract the motor from the vehicle, as I predicted, and exchange that with a new motor, or let someone rewire the motor, which is probably going to be the only option, because the Twikes use a very specific motor setup that is also used as a transformer for the charging process. So during driving, the motor controller sends a 3-phase AC in the right frequency to the motor, so it turns the right way, and during charging it disconnects one phase and uses 2 of the phases to act like a transformer and convert the AC voltage from the grid up to the 400 volt DC and charge the battery through the motor, which is genius and is done by a few other cars by now, but like 30 years ago, that's crazy. No one did that. There are, however, a few drawbacks as well. This motor is designed to have an output of 3 kilowatt, peak 7 kilowatt I think, and most people drive above the nominal power output, so the motor gets warm and isn't designed to remove the heat properly, because there is no cooling system at all. And that's also like the main problem I think for these motors breaking down, because guess what? This Twike behind me also has a broken motor, just like this one. The thing is, these motors weren't designed to run at that high power or for that long of a time, because 30 years ago these Twikes didn't have lithium iron phosphate batteries but lead acid. And these lead batteries were dead way earlier, so the motor never ran for more than like a half an hour at peak performance. Now we can drive around for an hour or 2 and the motor is like toasting hot, and when we get home we plug it into the charger and then the motor acts as a transformer and gets even hotter, because it has to transform the charging current into the batteries, and it always gets used above its designed performance, and no wonders at some points after 20-30 years these motors break down. I'm definitely going to ask the rewinding firm to put a higher temp installation layer on it, or use different coils than are in there right now. And also, if it's driving again, there will be a project of me building a proper cooling system for this motor, so we can drive around with a peace of mind for a longer time and also have a temperature controller that monitors the temperature. So maybe I'll find a way to integrate that in the motor, and if not, I'll have to figure out a safe temperature from the outside to reduce the power. That's all for this video. Thank you for watching. Also subscribe and comment down below what I can improve with the videos and what questions you have. I'm very open and looking forward to reading your comments. In the next videos, I'll have to figure out a way how I can remove this lower chassis part so we can start extracting that motor so we can try to repair it. Thanks again, and I'll see you in the next video. Peace out.